Now, for adding and subtracting algebraic fractions, the rule is very simple. Any fraction, doesn't matter whether it's algebraic or numeric, in fact, must have common denominators before combining them using addition or subtraction. That even includes comparing two fractions. So if you wanted to compare, for example, 1/2 with 1/3, you cannot compare those two fractions, I might just write them here, so versus 1/3, unless the denominators are common. So the same rule applies when there's pronumerals. After all, pronumerals take the place of numerals, so we can treat algebraic fractions effectively as numerical fractions, but the rules are slightly different when dealing with adding and subtracting like terms, of course. Let's have a look at some examples. So simplify each of these expressions. Okay, so the first one, x over 3 minus x over 4. Denominators need to be common before we can proceed any further. And the way we could do that is you just multiply each fraction by the denominator of the other. So with the second fraction, we can multiply the numerator and denominator by the 3. So if we multiply top and bottom by 3, and the first fraction, multiply top and bottom by the denominator of the second fraction. All this is just so we can have equivalent fractions where the denominators are identical. So if you multiply top and bottom here by 4, you're going to end up with two fractions with a denominator of 12. So the first fraction, the equivalent fraction 2x on 3 is going to be 4x on 12. And the second fraction, x on 4, its equivalent fraction is 3x over 12. Now we can subtract the numerators from each other if the denominators are identical, and they are in this case. So 4x minus 3x is x on 12. Part B, 2a plus 2 on 3a. Again, same rule applies. It's just all about making the denominators common. Okay, so the first fraction is 2 on a. It'd be good if we had a 3a here. So if we multiplied top and bottom by 3, the resulting fraction will be a fraction with the same denominator as the second fraction. So 2 times 3 is 6, a times 3 is 3a, plus 2 on 3a. So the second fraction, we don't have to do anything to that. Okay. So when looking at common denominators or looking at producing fractions with common denominators, equivalent fractions, you don't have to necessarily multiply every fraction by something. It may be that just only one fraction needs to be multiplied by a constant to make the denominator equal to the other fraction. Now that the denominators are identical, we can just add the numerators together. So 6 plus 2 is 8 over the common denominator of 3a. Right. Okay. What about this one? A over b plus b over a. So I guess one strategy to look at here is to see what's missing in the denominator that you would like to see there. So with the first fraction, the denominator is a b, but it'd be nice if we had an a there. Okay, so if you multiply the first fraction by a, top and bottom, so numerator, denominator by a, we would have an ab on the bottom. Now the second fraction would be great if we had a b in the denominator. So because the first fraction has a b in the denominator, so that should also appear in the second fraction as well. So let's multiply that by b and multiply the numerator there by b. So now we're going to have two fractions where the denominator is ab. Okay, but let's see what the numerators are now. A times a is a squared. B times b is b squared. Common denominator, so we can combine the two fractions now. So that's a squared plus b squared, okay, all over ab. Okay, and I guess splitting this fraction up to go back to where we started, which is a over b plus b over a, is probably not an easy thing to do. So it's pretty hard to see, I think, that a squared plus b squared over ab is a over b plus b over a. Okay, but anyways, it's good to see that process, I guess, and to see that these two statements or these two expressions are in fact equivalent to each other. Let's have a look at D. So this is a plus 1 over 2 minus 2 minus 3a over 6. Now 2 is in fact a factor of 6, or 6 is a multiple of 2. And in fact, this would be just multiplying it top and bottom by 3, in fact. And this will mean that the first fraction will have a denominator of 6. We don't have to do anything to the second fraction. Also, something for you to realize is that 2 minus 3a should be in brackets. We don't show the brackets when there's fractions involved because brackets are implied. Okay, we assume that they're there even though we don't necessarily show them. And this is important later on, and you'll see why. The first fraction, let's multiply top and bottom by 3. So a plus 1 times 3, that's just 3a plus 3 over 6 minus 2 minus 3a over 6. And notice that I've put brackets around the 2 minus 3a. This is a very important step. It doesn't matter so much if it's all just positive or just plus signs or addition. But when there's subtraction involved, especially when you're subtracting a fraction where there's a difference in the numerator, you're going to have a case of a double negative, which means that one term is going to become positive. Okay, so just writing it in full. So we've got 3a plus 3. I'm going to combine the numerators, minus 2 minus 3a. Okay, and that's all over 6. Okay, now let's collect the like terms. I'll just put hopefully I have enough space there. Okay, so we know that the denominator will be over 6. So we've got 3a minus 3a, that's 6a. Okay, so 3a minus 3a is 6a. And we have 3 minus 2 is positive 1. Okay. Let's all look at part E. 1 over x plus 2 plus 3 over 4. Okay, so have a think about that for a moment, see what we can do. Okay, looking at both fractions, it'll be great if the first fraction had a 4, and it'd be great if the second fraction had an x plus 2 in the denominator. So I'm talking about the denominators here. It doesn't matter so much about the numerators, right? The numerators don't factor into this. It's more that, you know, we need to focus on the denominators being common. So let's do that. The first fraction, let's multiply this one by 4. So I might just put it here. So 4 times and 4 times the denominator. I'm going to put this in brackets, of course. There's implied brackets there. And the second fraction here, it'd be great if we had an x plus 2 in the denominator. So we're going to multiply that by x plus 2 and the numerator also by x plus 2. With equivalent fractions, as long as you multiply the numerator and denominator by the same thing, then it doesn't really matter. Okay, so multiplying through now the numerators and the denominators of both fractions. So we have 4 times 1, okay, which is 4, over 4 times x plus 2 in brackets. So this is just a distributive law. 4 times x is 4x. 4 times 2 is 8. Plus, now 3 times x plus 2. Again, just binomial expansion. 3x plus 6 over 4x plus 8. Okay, now we have the denominators are identical, they're common, we can just add the numerators now. So 4 plus 3x plus 6, that's going to be 3x plus 10 over 4x plus 8. Always check to see if you can simplify the fractions. So, and you simplify that by factorizing out the highest common factor. For example, we can factorize out 4 out of the denominator, but we can't factorize anything out of the numerator. So that's as simple as it's going to get. Okay, last one. 1 over AB plus 1 over BC plus 1 over CD. Okay, so again, common denominators. All right, we have an AB in this fraction here. It'd be great if we had an A in the second fraction, but then we're missing an A in the third fraction. So we can see here that we have 4 different pronumerals, 3 fractions. I think we can see that we need an A, B, C, D in each of these fractions. So if we multiply the first fraction by CD, Okay. So top and bottom by CD. Second fraction, okay, multiply this one by AD. And the third fraction, multiply top and bottom by AB. Right. Now let's multiply through the numerators and the denominators by the terms that we've selected. So 1 times CD is CD over ABCD. Plus. Now 1 times AD is just AD over ABCD. And lastly, 1 times AB is just AB over ABCD. Okay. So we now have 3 fractions with a common denominator of ABCD. Now we can just combine the numerators together. So we have AB plus AD plus CD. It doesn't really matter which order you do them in, but I'll sort of keep it in somewhat alphabetical order. All over ABCD.